Dr. Thompson here. I'm going to review exam 4 for 145. I'm going to start with these implicit differentiation problems that you can see here on this sheet. I'm going to start with this one. So this is x squared plus y e to the y equals x. And we're going to find the tangent line at 0, 0. So let's go to the next page. Go ahead and write the equation again. The point of these first two is to make sure that we understand how the product rule works with these implicit differentiation problems, because these curves are not functions, but we can still take the derivative. So let's take the derivative with respect to x, and I'm going to get 2x. Now here I'm going to use the product rule on y e to the y. Y becomes dy dx. Let's get that line in there. And e to the y is going to stay how it is. Then y stays how it is, and e to the y's derivative is e to the y dy dx, because I'm working on y, not x. And that's going to equal 1. Now, in the corner, I wrote down that, hey, we're at 0, 0, and I'm going to use that right now, because I don't want to solve for dy dx. I just want the slope. So let's make x and y 0. So that's going to kill this term and this term. But e to the 0 is 1. So this middle term will just be dy dx times 1. That's going to equal 1. So dy dx is 1. And of course that means the slope of this line is 1. The point is 0, 0. So you can figure this out with point-slope form or with slope-intercept, but either way the line is y equals x. I would strongly encourage you during the exam, and right now, after you do this, graph the original curve, this guy, in Desmos, and graph the line here, and just make sure, hey, that looks like the correct tangent line. Alright, so that's the first one. Alright, now we're going to go to number 2 here, which is the toughest of the three. The third one is actually the easiest one. This is xy squared minus y e to the x equals 4 at the point 0 minus 4. So let's go ahead and write that on a new slide. Okay, so we've got the equation here, and now I have to do the product rule twice on this side when I take d dx. And these have x and y mixed in. So the first one, if I make x 1, I leave y squared, and then if I change y squared to 2y, I tack on dy dx. That's because I'm differentiating y. Now, here, the second term, I need to use parentheses, because that negative is going to distribute across my whole product rule. So let's make y dy dx. And then let's not do y, let's do e to the x, which, of course, is its own derivative. And this will all equal 0. Alright, so yet again, I'm going to now plug in x and y. So when I square y, that's going to be positive 16 when I square negative 4. And of course, when x is 0, this guy is gone. So this is going to be now minus dy dx times e to the 0, which is 1. And it's going to also be plus 4, because y is minus 4, when I'm thinking about this guy here, and e to the 0 is 1. So this is all going to equal 0. And if I move dy dx to the other side, the slope is 20. So now let's go ahead and use point-slope form to combine my point and my slope. Okay. So this is going to be y plus 4 equals 20x minus 0. Or if you want it in slope-intercept, I guess it's going to be y equals 20x minus 4. And I guess the point given was the intercept, so you could also do it that way. Either way, there is your slope and points, so there's your answer. I would again strongly encourage you to graph the curve and the line and make sure, hey, that actually looks like the tangent line. Okay, so we are to number 3 here, which is actually the easiest one. So let's go ahead and put that on a new slide. So the nice thing here is that there's no product rule to do. X cubed becomes 3x squared. Y squared becomes 2y dy dx, and of course the constant becomes 0. And if we make both points 2, then I've got 12 plus 4 dy dx equals 0. And I need to solve that for dy dx. So 4 dy dx equals minus 12. So I guess the slope then is minus 3. And I would go ahead and just use point slope on the slope. This would be, let me put it in the corner here, y minus 2 equals minus 3 x minus 2. And yet again, put that in Desmos along with the curve to make sure that that is correct. Alright, so that is the section on implicit differentiation.